A buffer solution is prepared from equal volumes of 0.200 molar acetic acid and 0.600 molar sodium acetate. Use 1.80 times 10 to the negative 5 as the Ka for acetic acid. And then we solve. A, what is the pH of the solution? We're going to use the Henderson-Hasselbalch equation here. So pH is going to be equal to the pKa plus the log of the concentration of the conjugate base over the concentration of the weak acid. Now from here we just plug in what we need to and solve. So the pKa, you need to take the log of 1.80 times 10 to the negative 5th. You should get 4.74 plus the log of the acetate is going to be 0.600. 0.200 is the concentration of the weak acid. Put all of that into the calculator and you should end up, if you do it stepwise, this log part reduces to 0.477. So the new pH is 5.22. Now, if we use the ice method in order to solve this, this acid dissociation, we start with 0.200. We have 0.600 for the acetate. We're going to shift with some value x. We set up our Ka expression. We can reduce this, we can simplify this because our initial concentrations are more than 1,000 times greater than our Ka. So when we solve this, we solve in x is 6.00 times 10 to the negative 6, capital M molarity. So then to find the pH, because this is the concentration of the hydrogen ion, to find the pH, we take the negative log of this value, and the pH is 5.22. So you see it doesn't matter which way you solve it, you should end up with the same solution. So B, is this solution acidic or basic? Well, a pH less than 7 means this is an acidic solution. And C, what is the pH of the solution that results when 3 milliliters of this hydrochloric acid is added to 0.2 liters of the original buffer? Well, first thing we need to do is calculate how many moles of each of these items we have. So if we have 200 milliliters, so 0.200 liters, we're going to multiply that by the initial concentration. So for the weak acid, it's 0.200. That's moles per liter, so that we're left with moles. So then I have 0.0400 moles of my weak acid. Now for my acetate, again, I have my 200 milliliters, multiply it by the concentration so that I'm left with moles, and I end up with 0.120 moles of the acetate. Now I'm adding a strong acid. So I need to do that calculation as well. Find out how many moles of acid I'm adding. So it's 3 milliliters. I'm just going to truncate here for brevity. It's 3 milliliters times the molarity, 0.034 moles per liter. This is my acid. So I have 1.02 times 10 to the negative 4 moles of strong acid. Now when I add that strong acid in, that's going to react with my acetate. So it's going to remove some acetate and make weak acid. So I need to remove 1.02 times 10 to the negative 4 moles of this, and I need to add 1.02 times 10 to the negative 4 moles to my weak acid, because that acid is reacting with that conjugate base in order to make more weak acid. So I do this quick arithmetic here. And I get my new moles. Now I need to calculate my new concentrations. So now my total volume is 203 milliliters, if I'm not mistaken. We had 200 milliliters of our buffer, and we had 3 milliliters of acid, so 203 milliliters. So I need to divide both of these by 0.203 liters in order to get my new concentrations. So my new concentrations are 0.1975 capital M molar, 0.590 capital M molar. Now you can run through the ice equation again. So if we run through the ice equation, if I set up my Ka, 1.8 times 10 to the negative 5, I have X for my H value. I have 0.59 plus X for my acetate, 0.1975 minus X for my weak acid. So this becomes my initial. We can simplify this and then solve for X. So when I solve for X with this value, I end up with 6.03 times 10 to the negative 6, that's capital M molarity, and that's the concentration of my hydrogen ion. So now I can find the pH by taking the negative log of this value, 6.03 times 10 to the negative 6, and I get a pH of 5.22. Now, because we have a buffer solution and after we have adjusted with our strong acid, we can take these mole values here and plug them into the Henderson-Hasselbalch equation. And if you do that, you should find that you also get a pH of 5.22. Remember, the Henderson-Hasselbalch equation can be used when you can do this simplification. If you can't do this simplification, the Henderson-Hasselbalch equation will not work.